And we are live. Welcome everybody for this live stream where we are going to code a dollar cost averaging app for crypto. So this is going to be a very interesting project. You can basically see this as a sort of trading bot that is going to invest automatically your crypto. And so basically, we are going to use a couple of technologies. Of course, we're going to use Solidity, which is the programming language for smart contract. We're going to use Ethereum because this is where most of the trading bots are running and where you have most of the opportunity. And what's really amazing with this trading bot is that you can not only use it for yourself, but you can also offer it as a service. Like basically run this as a service and charge a fee and make money from it as an entrepreneur, basically. So they're also going to be a front end part to this project because we need to allow user to use our app as well. So it's gonna be interesting. There are gonna be several parts. All right. So who do we have in the chat? We have THX tonight. Amazing. Where you guys are from? Let me know in the chat. Hey, also, I'm curious. Are you guys a complete beginner, or like, what's your background? Like, are you a beginner in blockchain, a beginner developer, more experience? Let me know in the chat. All right, so we're gonna get started. So let me share my screen. All right, so if you are completely new here, and you want to become a blockchain developer, check out my free training, eattheblocks.com roadmap. So basically, in this free training, I'm going to tell you everything step by step, everything that you need to learn and how to get your first job in the space. So it's going to save you a ton of time. I put a lot of work in this free training, so just go register for it. Really, it's gonna be very beneficial. All right, so we start to have some people in the chat. Abby, Tim, hey, Pepe Loco, Nicolas from France, people from Morocco. Abby, complete beginner, no experience. All right, so first of all, what is dollar cost averaging? Okay, so let me pull up a chart of Ethereum actually, because we're gonna do it for Ethereum. But this is a strategy you can use really on any asset. Ethereum. So you can see Ethereum, was very volatile. It goes very high, it goes very low, and so you have all these guys who try to know exactly when is the best time to get in the market. And the problem is that it's very difficult to time this. So there is a very simple strategy that is very powerful. Is what if you buy the same amount, but at a regular interval? So without trying to understand, hey, is it too expensive? Is it or not? Basically, you can say, for example, every beginning of the month, you just buy the same quantity. Let's say for $1,000 of Ether. So if today Ether is $3,000, then that means that you're gonna buy 1/3 of an Ether. But if the next month Ether completely collapse to $1,000, and then you're not gonna get a full Ether. But if next month Ether explode to, let's say, double, let's say $4,000, well, now you're gonna get just a quarter of an Ether. So you never change the dollar allocation, but what's going to change is the quantity of the asset depending on the fluctuation of price. And so why are we doing this is because what's going to happen with this strategy is that when when the asset goes down, basically you're gonna buy more of it, okay, which is good because you want to buy more when it's cheap. And when the asset goes up, you're gonna buy less of it. So if you do this for several years, what's going to happen is that you're gonna have an average purchase price that is usually way better than whatever timing you would have picked. So let's say you have, like, I don't know, let's say you have $12,000 to invest, and if you try to time the market, it's very likely that you're gonna fail. But with this strategy, if you invest $1,000 every month, so you basically spread out your investment over 12 months with this strategy, most likely you're gonna have a better average price. So that's all we need to know about this strategy. Now it might seem a little bit too basic, so maybe you wonder, hey, like, really, like, is this, why is this even a trading bot? It's because, you know, a lot of people know about this strategy, but it's easier to explain it than to actually implement it. Because what's the big temptation here? When the market goes up, most people are okay to follow DCA, and when the market goes down, like by chance, people start to have doubt. They say, oh, maybe I should wait the next month because really it keeps going down. And then basically they break the strategy, because what if the next month now it start to go up again? Then instead of buying when it's cheap, then you're gonna buy when it's more expensive, so your average price goes up. So it's very, very difficult to be disciplined for this strategy. And so basically with a smart contract and a trading bot, we can force ourselves to be disciplined. The idea is that we're just going to put money in a smart contract, and then at a regular interval, this smart contract is going to buy Ether. So it's going to take the money that we put inside, for example, stable coin like USDC or Ether, and it's going to buy, basically sell those stable coin against Ether. So let's say you put $12,000 of USDC in your smart contract, and then every month it's going to sell $1,000 of it, and with it it's going to buy some Ether. So really that's the idea. How are we going to do this? So first of all, we are going to create our smart contract. So we are going to call this DCA. All right. So let me increase the font size. So if you never seen this, that's basically remix.ethereum.org. That's an online coding platform for Solidity. So everybody can code smart contract for that. So I'm gonna put the link in the chat. There is nothing to install, so it's easy to get started. So the language we're gonna use, as I mentioned, is Solidity. Here, this programming language, and it looks like JavaScript on the surface, but it's actually quite different. So once you are on Remix, you can create a new file with this button. And then we're gonna name our first smart contract DCA.sol. We're gonna start like this. And what this statement does, basically you're saying, hey, I'm gonna use this version of Solidity. So next we are going to define our smart contract. All right, DCA. And everything that is inside belong to the smart contract. So we're gonna have some data, and we're going to have some function as well. And everything that is outside of this is not in the smart contract. So here we are going to start with a function. So we're gonna have a function to send money to our smart contract. We're gonna call this fund, okay, and we're gonna put an argument here. So this is how you pass data to a function. So a function here, This is what you call to interact with the contract. This is like an action you take. And here, that means you're going to pass an information. So we're going to pass an information that is amount. So how much we want to fund the smart contract. And here, external, that means we can call this function from outside of the contract, because there are some function that where you cannot do this. And here, what we're going to do is we're going to transfer some token. So we're going to choose USDC, but really you can choose whatever you want. So we're going to transfer USDC to the contract. All right. And how are we going to do this? So we need first to import something. So I'm going to copy paste this. All right. So here we are going to import from GitHub. So GitHub, this is basically where a lot of people share their code, and there is a library for Solidity that is called OpenZippling. So this is like some ready-to-use code that other people have prepared for you, and you are guaranteed that this code is secure and it's working well. And so OpenZippling is the most famous library for Solidity. And so here, basically, you specify in this library what you want exactly. And what we want is this this file, irc20.sol. So that's called an interface, and we need this if we want to transfer USDC. So here, I'm just going to show you quickly what it is, because you can actually visit it. You can so if you load this in your browser, you can see the code of OpenZippling and this file irc20. And so it defines here a few function of what we call ERC20 token. So this is a kind of asset. So if you go on Etherscan and you type here USDC, basically you're gonna find an example of ERC20 token. So this is an asset that is always worth $1. One USDC equal $1 all the time. And if you click here, you can see the code. So you click on contract and code. And okay, so here this is a proxy, so just slightly more complex. So I'm not going to explain exactly what is a proxy. This allows you to update the smart contract, but this is not the proxy that I want. Let me see. Let me see. I'm trying to see how I can find maybe read as a proxy. Oh, implementation contract. That's this one. Okay, so here this is the actual contract. And here, you don't have to understand all this code, but here what's interesting is that this, let me scroll down, because there are several contracts actually. So some of this function here, okay, so here it's more clear. IRC20, okay, so transfer, allowance, etc. So you can see that this is the same thing as what we have here. So yeah, so this is how basically you can read the code of an ERC20 token on the blockchain. But we don't need to understand everything. All we need to do is just to import this, and then we can interact with USDCA. So this is what we do here. So let me see first what we have in the chat with a couple of messages here. Pepe Loco, I've been mid-developing and I'm moving to app because it will be next big demanding thing, blockchain project. Okay, awesome. All right. Pepe Loco, can this work on Solana as in Rust? No. This is going to work on EVM blockchain. So yeah, EVM blockchain, this is everything that is based on Ethereum, so not Solana. Okay, so we have our import. Next, we need to define a variable that is going to point to USDC. So we do this like this: IERC20 public USDC. So what is this? First of all, we declare that we have a token. We're gonna have a variable of type IRC20. This is what we just import public, so everybody can see it from outside the contract. The name of our variable is USDC, and then we are going to give it an initial value, and we need to pass it the address of the token. So each smart contract here has an address that's basically like an account number if you want. This is how you identify the contract. And so we can find the address of USDC. So let me come back here. We are on USDC. And you click here, this address 0xA0B, and you go in your contract, and you're gonna put this address here. And so now we can interact with USDC. Okay, awesome. So with this, we can transfer USDC. So USDC, let me see, transfer from, and so there is a function on USDC that allow you to transfer token, and this is transfer from. This is what we call delegated transfer. So the flow is a little bit complex. So it's not like the user that is going to send directly fund to our DCA contract. This doesn't work like this. For a token, basically the user is going to it's going to approve DCA. Okay, so it's going to say, hey, DCA has the right to spend my token. And then from DCA, we're going to say, we're going to call transfer from. That is going to, so we're going to basically take token from the user to DCA, but this is going to work because the user has approved us before. So of course, if you try this with the user that did not approve you, it's not going to work. So here, MSG sender. So from the sender, and after that, the recipient address is the address of our smart contract. And for the amount, this is what we specify here. Okay, so we transfer some USDC to the contract. So with this, we can use this USDC to do our dollar cost averaging. So what else? So we're gonna do another function that is easy. So to withdraw money, because basically we're gonna invest in Ether, but maybe that at some point we want to withdraw this Ether. So we are going to create another function to withdraw it. All right, and here we are going to send some Ether to ourselves. So MSG sender, that's basically the sender of the transaction. So that's ourselves. And here the syntax to send us token is like this. Right. So the syntax is not straightforward, but that's the way it is. All right. So we have a big problem here. Big problem, because what happened with this function? Okay, just think about it. If you just call withdraw like this, what's going to happen? What's going to happen is that everybody can steal your money. So do you want this? Of course not. So we need to protection to make sure that only people who have access, only the owner of this wallet is able to withdraw. So for that, we're gonna define a new variable. So we're gonna call this owner, address public owner. So here we define a variable of type owner, of type address, sorry, and this is gonna be the address of our wallet. And we need another function to know what is this, to set the initial value of this. So call this initialize, and this is let me see, Okay, let's do constructor first. After we're gonna change it to initialize, but now let's make it simple. So constructor, this is a function that you call when that is executed only once when the contract is deployed. So here, right? So we have our sender, and here what we're gonna have is that we make sure that the sender of the transaction is the owner. Okay, owner only. All right, and we also need to make sure we have enough money. Anyway, it's not possible to, this call is not going to succeed if we don't have enough money, but we're not gonna have a clean error message. So if we wanna have a better error message, we need to pass another condition. So the other condition is like address this dot balance. So we need to make sure we have enough money. And here with these two required statement, what's going to check is that we test if this condition is true. If yes, it just continues. Otherwise, it's going to throw an error. The execution is going to stop, and we're going to see this error message. And same thing with this required statement. All right. So yeah, I see in the chat that some people find a problem with withdraw. Awesome. So now we have withdraw is working. So the next function that we need is the invest function. And this function is going to be called at regular interval, so every month. And in this function, what we're going to do is that we're going to invest some of our money in Uniswap. Okay, so how are we going to do that? So first of all, we need to make sure that we don't invest too soon. So we want to have at least 30 days after the last investment. And here we're going to define another variable, and it's going to be of type uint. So the way we deal with time in smart contract is that we use a variable type for integer. Okay, so it's going to be a number, a big number, and that's basically what we call a timestamp. That's an integer that is the number of seconds since 1st of January of 1970, and this is how we deal with dates when we write code. And so you can see the current timestamp. So yeah, here's the current timestamp. So this is this big number, and you can see that every second this is incrementing. All right, so this is going to be the timestamp of the last investment. And the error message is going to be, let me see, too soon. Yeah, we invest too soon. Okay. Then what else? Is it important that this is do we need to check who called this contract? Is it important that this is the owner of the contract that called this? Well, not really, because we need to make this investment anyway. So we don't care who called this contract. And after that, we are going to call the function of we are going to call the function of Uniswap to do a swap. Okay, and so for that, we're gonna check out a special smart contract of Uniswap. So first of all, if you never heard of Uniswap, okay, so what is Uniswap? So Uniswap is what we call a decentralized exchange. So it allows anybody to buy and sell tokens, but in a decentralized way. So that's very different from what we call centralized exchanges like Coinbase, Kraken, etc., because those store the crypto in a centralized manner. But on Uniswap, everything uses a smart contract. So basically, users are always in control of their fund, and there is no KYC. So they have their app. So here you have a front end. So you specify how much ETH you want to buy. So let's say I want 10 ETH. I want to buy 10 ETH, and then with which token, USDT. But you can also do the opposite. So let's say you spend 30,000 USDT. This is how many ETH you're gonna have, and you can choose the token you want here. For example, USDC against ETH, and this is the trade that we are going to do. So there are a couple of smart contracts with Uniswap, and it can be pretty complex. But fortunately for us, fortunately for us, there is just a single contract that we need to know, and that's this one. So it's also on GitHub. This is on the repository of Uniswap, and they have this contract called Uniswap V2 router. So just for the record, for FYI, there are different versions of Uniswap. What I show you here is V2. There are some more recent version of Uniswap, but those more recent versions, they're really more complex. So actually a lot of people are still using V2. So if you're getting started, I also strongly recommend to just to study this. It might be enough. All right, so here we don't need to understand everything, but I'm gonna show you what really matters. So let's scroll down, and what we're gonna have is swap tokens. Let me see. Swap tokens for exact ETH. Swap exact token for ETH. Okay, because basically we know exactly how much token we want to spend. So that's basically 1,000 USDC every time. But we're not sure of how much ETH we are going to receive. And I'm not going to show you how we're going to protect ourselves against this, but that's the function that we're going to call to buy ETH with USDC. And okay, let me zoom in a little bit because I think it's a little bit small, right? Okay, let me find it again. Just 1 sec. Swap exact token for ETH. Okay, so there's the first parameter, amount in. So that's how much USDC you are going to provide. Amount out means, so that's how much ETH you want to have minimum. Okay, so it means that you can tell Uniswap, okay, I want this amount minimum. So maybe you wonder, okay, why can't we just tell Uniswap, hey, I'm giving you 1,000 USDC and I want 3,000 and I want 300 ETH. And I want a certain value of ETH in output. That's because the market is moving all the time. So maybe that at the time where you check out the prices, this price makes sense, but maybe by the time your transaction is mined, that means this is accepted on the blockchain, maybe that this price will be completely different. So if you have zero tolerance, you have zero chance of having your trade accepted. Okay, it's gonna be your trade is going to fail all the time. So we need to have some tolerance, some flexibility, and this second parameter, this is how you indicate this flexibility. Now the big question is, well, how much flexibility? Well, it really depends on your own preference. Then call data, so that's basically an array of addresses. So that is the asset that you're going to sell and the asset that you are going to buy, address to, who is going to be the recipient of this trade. So you're going to sell something and in exchange you're going to get something else, so where this something else will be sent. And then the deadline. So the deadline is very important because that's your way to indicate, hey, at this time, this transaction makes sense. So I want to sell 1,000 USDC, and in exchange I want a certain number of ether. Given the current market price, that is acceptable. But what happened if you send this transaction and for some reason it's not mined right away? Because before a transaction is processed, it actually takes time, because you need miners to accept your transaction and to add it on the blockchain. This can take several minutes, but sometimes it can take 10 minutes or even 1 hour, 2 hours. And so maybe the price that you indicated right now, maybe in 1 hour, it doesn't make sense anymore. And so how do you protect yourself? Well, with this block timestamp. This is how you indicate, hey, this is the time limit. And so what is it, block timestamp? Well, remember before I told you that on smart contract, in smart contract, we use integer to deal with time with the so-called timestamp. And each block that is added to the blockchain, so basically the way the blockchain works is that you have all those blocks that are added all the time, and each of them has a specific timestamp. And so with this deadline, we can protect ourselves. Okay, so after this function does all sort of things. But here's the part that is really great, is that we don't care. We don't care because all we need to do is to understand what we call the function signature. We only need to deal with this part. After, this is Uniswap that is going to do its thing, and we are not concerned anymore. So we're just going to copy paste this. Right. Are you guys following? Anybody lost? You guys still here? All right, so here, let me put this here. Okay, so we're gonna call this function, but to call this function, we need to have a pointer. So basically, we need to have a variable that we can call, so that we need to have a variable that points to this smart contract. So remember how we did it before with OpenZeppelin? Well, it turns out we can do the same thing. We can do the same thing with the router of Uniswap. So we're going to import, let me see. Actually, I'm going to show you from here. So let's go here to interfaces, Uniswap v2. All right, let's copy this. Let's go back to Remix. And right, I'm gonna import this. And yeah, it's working. All right. Forgot semicolon, very important. Okay, so now we need to define a pointer to this contract. So we need to use the interface. So let me copy paste this, and to define the router. So let's do it again. And now we need the address of the router. So there are different ways that you can have it. So with the doc, we can have it Uniswap v2 router. And let's see here. Uniswap v2 router is deployed at 0x7a on the Ethereum mainnet. And this is the same address on different other blockchains. So Ropsten, Ring, Big Wally, all of this is testnet. Yeah, but we're going to do it on Ethereum. So, all right, so we put this here. And so now with this router, we can buy and sell token on Uniswap. So we go here in invest, and here we have a router that swap exact token is for ETH. All right, so let's put this on each line to make it a little bit easier to understand. Okay, awesome. So amounts in, how much we going to invest? So this, we need to define a budget. Okay, when we when we first start with this smart contract, we need to define a budget. The budget will be how much USDC we're going to invest every month. And of course, we need to fund this contract enough so that it's able to invest that. Because if we set a budget, monthly budget of $1,000, but we just have 500, of course, this is not going to work. But this is the responsibility of the user to keep this contract with enough fund inside. So let's define a variable for this budget. And how are we going to do this? So we are going to define, if we already know in advance, we can do something very, very simple. We can define it like this. So for example, 1,000. Be careful here, this is a budget in terms of USDC, but USDC actually, if you put 1,000, it's not gonna be what you think. It's not gonna be $1,000 worth of USDC. It's gonna be way less than this, because USDC has a system of what we call with decimals. So basically, it's like a fraction of a USDC. And how much is this fraction? So it's not like a cent. It's actually much smaller. And we can see this if we go there, read contract. Let me see, read as proxy. So I spare you the detail, but basically, if you want to interact with USDC, you need to click on as proxy here. And if we click on decimals, we can see that it has 6 decimal. Okay, so if here we want a $1,000 per month, it's not 1,000, but it's gonna be times 10 power 6. Yeah, I think this is the power operator. Yeah. Okay. So everybody's following? Yes. So let's keep going. And so here, how much we're gonna have in amount in? So that's gonna be the budget, right? And amounts out mean. So, it's not possible to know this in advance. So this is gonna be something that we're gonna get from outside. So we're gonna put amount ETH mean. Okay, ETH mean. Basically our tolerance, the pass. Okay, the pass is this array that we need to define. So what we want to sell, what we want to buy. So we're gonna define an array of addresses like this. And new address, and here this is gonna be an array with two entry. So the notation is a little bit difficult, but basically it means an array with 2 addresses. So you're gonna have like here one address and here another address. That's all that means. But right now this is just an empty array, so we need to populate it. So first, the asset that we want to sell, so that's going to be USDC. Okay, and so this is how you transform a pointer to its address. And second, the address we want to, the asset we want to buy. So Uniswap router. And here, so we refer, okay, let's router. So that's what the variable we have here. And it turns out that when we want to buy Ether, here we're going to get to call this function. So this is called wrap Ether. That's a special version of Ether that is wrapped in a token. But what we're actually going to get back here is just normal Ether, but it still expect a pass. And in this pass, in this case, here we put wrap Ether. Okay, so let's go just to make sure we have this function. So let's go back here, contracts, router, and let me see. So here in this constructor, they instantiate wrap Ether, and we should have the function somewhere. Function. Okay, where is it defined? So maybe it's some of the yeah. So here basically we define a variable and we make it public, which automatically create what we call a getter function. So you don't see the function defined, but it's available to you. Okay, so let's go back to Remix. And so here we're gonna have our pass. Then who's gonna receive this? Well, it's us, which is gonna receive it. Right. So address this. Then the deadline. So the deadline, this is also something that we're going to pass here. So uint deadline. Okay. So here we're going to close all of this. All right. And we also need to update the last investment variable so that it's next time we want to call invest, basically this is going to we make sure that we cannot call invest just after. Okay, we need to wait 30 days. Oh, by the way, let me see, I forgot this. So in Solidity we can write like this 30 days, and so that's basically, it's going to transform this into the number of seconds, so 86,400 times 30 basically, but it's just more simple to write 30 days. Okay, and is this everything that we need to do? Unfortunately no, because what's going to happen in this function is that it's going to call USDC transfer from. Remember I told you when we send an ERC20 token to a contract, we actually don't send it directly, but we approve it, and then it's the recipient contract to call transfer from. And so that means, so before here, we were the one that were pulling the token to us. But in this case, we need to approve Uniswap to spend our USDC. So USDC, then approve. And who are we going to approve? So it's going to be router. And for which amount? Well, it's going to be for our budget. Okay, so we approve you for the budget, and after this execution, basically the approval budget is going to be reset to 0. So Uniswap, once it has spent our $1,000, it cannot spend it again. So next time we do the swap, we need to call approve again. Okay, and so with this, basically this is how we buy Ether with USDC. So this is the smart contract part, but now we need to make sure that this smart contract is going to be called at a regular interval. And the big problem is that it's just not possible to ask the smart contract to trigger itself. So in JavaScript, we can do something like set timeout, etc., and with another function. And so basically we can ask JavaScript to regularly code itself, but this is not something that we can do with a smart contract. A smart contract can only react to incoming transactions. And how are these transactions sent? From some code outside. So JavaScript, Python, whatever language you want to use. But we are going to use Node.js because that's just the easiest. So how are we going to do this? Someone saying Phantom, is this an okay project for a CV for a junior position? Yeah, but you will need to polish it, of course. You will probably need to give it a front end and really make it really nice. All right, so let's see how this is going to work. So we need to basically create the backend. So for that, we are going to create a new project, and we're going to call this crypto DCA backend. All right. Now let's go there, and I'm going to initialize a new Node.js project. So if you've never heard of Node.js, that's basically JavaScript on the server. Node.js, so JavaScript, that's the most popular language for the web. You can run it on the front end and you can run it on the server. And when you run it on the server, we actually call this Node.js. So you can install Node.js on any platform. And after here, I'm on a terminal, and every operating system these days have a terminal. And okay, so next we are going to install a library, because in order to communicate with our smart contract, basically what is going to happen is that we need a library. Okay, so let's install our library. We're gonna call this ethers. It's called ethers, sorry. So here, if we check package.json, ethers is here. All right, and now we're gonna start the code. So here I'm going to start my code editor, which is Visual Studio Code, the Visual Studio Code here. It's the most popular code editor. You can install it on any platform. All right, so let's do this. And now let's zoom in a little bit. Okay, so we just need one file, and we're going to call this, for example, I don't know, index script.js. All right, script.js. And here, first of all, in order to have something recurrent, we can use set timeout. All right. Sorry, not set timeout. Set interval. And so set interval is going to take a function, and it's going to call this function at regular interval. So, for example, we can ask it to call our function that we're going to call init. Actually, you can give it init directly. Okay, init, and then we can specify the number of milliseconds that we want. So here, 86,400. So that's the number of seconds in a day. A time 1,000. So to transform it into millisecond, and then time 30. So that to make it every month basically. And after that, we define our function above. All right. So let me see, like this. Okay. And here we need to do several things. So first of all, we need to connect to the blockchain using ethers and infra. So ethers, this is the library that we just installed, and infra, this is what we call a blockchain API. So a blockchain API is a service that you can use to access the blockchain. And that's because in order to access the blockchain, you need to run what's called a blockchain node. So on Ethereum, this is an Ethereum node. This is basically a software. And everybody can run this software, but it turns out it's not so easy to run it. So you have those services that run this software for you and that allow you to access this software for free. They have free accounts. And if you want to more service, then have paid tier, but for tutorials or for pet project, this is perfectly enough. All right, let me see a little bit the chat, what we have. So 10 **6 means it means 10 power 6 basically. So that's gonna be 60. Then Phantom, is this okay project for, yeah, I already answered that. Igodaro, oh, it's just a tip. Use node daemon to apply change on your server automatically. Okay. So first step, connect to the blockchain. Then second step is gonna be build object to interact with smart contract. So by using ethers, basically there is a way to connect to a smart contract. Then what we're gonna do is get current price of ether and set our tolerance. So we also call this slippage. That's the professional word. So we're gonna, okay, so now actually first, in order to get the current price of ether, we actually need the we need an object to Uniswap. So here first, build object to interact with Uniswap using ethers. Right. Then build object, create. Then create object to interact with the dollar cost averaging smart contract using ether. And finally, send a transaction to call the invest invest contract. Oh yeah, and I forgot something, but basically this is not going to be in the init loop, but it's more like a sort of preliminary step, let's say. Preliminary steps. So one here would be to deploy the DCA contract, and two, transfer some USDC to DCA, because of course if you don't have USDC in it, then your DCA is not going to work. And yeah, and so that's basically everything we need to do. So we are going to start to do this. So first, connect to the blockchain using ether and infra. So what we're going to do is we are going to import ethers from ether. So while we are testing, we're actually not going to run this interval. We're just going to call init like this. It's just more simple. Right. And after we are going to connect to the blockchain. So how are we going to do that? So let me see. Saying here what we need is JSON RPC provider. Let me see the documentation. So connect to Infura with Ether. So Ethers, actually you have to be careful because there are a couple of versions. What we want is a version 6. All right, so they have an Infura provider. Okay, interesting. Infura provider. So let me see. They do have an Infra provider. Okay, so we can do this. So Ether, actually now in V6 we don't need this. Actually we can check this in the documentation. Ethers V6. So infra provider, community provider. Oh, let's see this one. Yeah, class infra provider. So yeah, it seems to be correct. So let's go back here. What else do we need? Here, Sepolia. Are we going to? Let me see. Are we going to deploy to Sepolia or not? Well, I'm going to show you how you would do it for mainnet. Okay. So your API key here. This is basically something that you will get from Infra. So if you log in Infra, so you're signing. And skip. And so basically, you click on create new. Okay, so now I cannot do it, but basically if you don't have any project, you can create a new API key, and so you're gonna select, you're gonna give a name to your new project, and after that they're going to give you your API key, and so you can copy paste it here. So you're gonna have something like this. All right, so infra provider, and after that we need an object to interact with Uniswap. So how are we going to do that? So here we need to, let me see, let me check my code how I did it. Just give me 1 second. Let me find my cheat sheet. So yeah, so here we have a contract object. So we're gonna have here the router, and we're gonna call contract, and the contract is going to take a couple of arguments. So we're gonna have the address. We are going to have what's called ABI. So the ABI, it's basically a JSON object that is going to describe the interface of the contract. And finally, here the last thing, so address AVI, and then we're gonna have the signer. So that's an object coming from the provider that allow you to sign transactions. So here, let's go back on the documentation of the infra provider to see if they have get signer. Let me see this. Get signer. So they don't have it. So they don't have a signer. Okay. That is a little bit annoying. They don't have a so the signer basically is something that you use in order to send transaction. Okay, well, we're going to solve this problem later. So here the address of the router, well, we already have it. So let's go to remix. So here, this is the address of the router. All right. So here we're gonna have a string like this, then the ABI. So the ABI, this is basically this JSON document that is going to describe the interface. But turns out there is actually a very simple way that we can do it. So either we find the ABI of the router, or there is a more simple way to do it if we just want to use one function, and I'm going to show you how to do this. So ABI v6 ethers. Let's check the doc. ABI. So it's not here. It's getting started. Contracts. Okay. Yeah. So basically you can give an array with the different function signature, and that's just much easier. So this is what we are going to do. Let me see. And oh, actually here we don't need a signer. A provider is fine. So here a provider will be completely fine. All right. And here, so we need the function signature of a function. So let's go in v2 router. And what we want is get amount. Let me see, quote. So let me see. And I start to have some doubt because actually those functions are a little bit annoying. Oh no, get. Okay, I get it. Get amounts out. So here, yeah, I think this is what we want. So we're just going to provide get amounts out. Just 1 second. So we're just going to provide amount in. This is the amount of USDC, and the pass is basically what we already did before in Remix. Okay, and so with this we're going to have what we want. So let's copy paste this. Okay, gets amount out. Okay, provider. And okay, and so this is new contract. And now we can call routers. Actually, we need to make this async. We need to make this async because we are going to call some function with the await keyword. So let me see. Amounts out. So it's get amounts out, and the amount in that we want to provide. So we say this is basically the budget, right? So we said that our budget is basically $1,000 times 10 power 6. Yeah, so the way you do power in JavaScript is different from the power in Solidity. So here this is budget, and then we need an array for the basically an array of addresses. Okay, so you know what, let's define two variables. So first one will be a USDC address. The other one will be Uniswap router. No, it's going to be wrap ether, sorry. And all right, so USDC, we already have it. So let's go back here. This one. All right, so let's go back. And then wrap ether. So let's see this. Let's see wrap ether. Wrap ether, we can just type it here, and we're gonna get the token contract. Okay, and let's go back to USDC wrap ether address. Okay, and actually let's clean up a little bit here. So router address. All right, so we have all our addresses defined at the same place. Router address. Okay, and here we're gonna have an array. So USDC address and wrap ether address. All right, and get amounts out. Okay, so next we can already console log this amounts out. All right, and we're already gonna have some first result. And actually I need to have the real API key, so I'm gonna define an env file. So this is a cleaner way to define your environment variable, infra API key. I'm going to install a dependency to easily load this value. So it's called .env, and how it works is that you just do, let me lower this, and how you do it is basically you do require, oh no, not this, require .env and then config, and it's going to load this in process .env the name that you have in your .env file. So here infra API key, for me it's going to be, actually let's just put it directly here. process.env.infra API key. Yes, okay. Okay, let me see in the chat what we have. All right. THX, why didn't you stream yesterday? I was too busy, unfortunately. Had a problem with the bootcamp. I had to replace an instructor that was sick, so yeah, I couldn't do both. Then Ego Daro, is the USDC address your own personal USDC address? No, so USDC is not my address. It's the address of this is a token that is deployed publicly, so that everybody can interact with this contract. Okay, so this is a public address. So if you buy USDC, this is gonna be the same address. Okay, so next we need to actually get this infra API key. So you know what? I'm going to remove this from your site. Okay, so that I can do it in secret. All right, so let me see. API key, endpoint, API key, setting. Where is this? It used to be very simple, but now it's very complex. No, it's fine. Reveal. Okay, so now it's copied. So now let me also move my editor. Okay, so you won't see it. Okay, now I'm gonna try to run it, see if it works. All right, so let me put it back inside. Okay, so now I try to run it, but there was a problem. Okay, so what's the problem? Cannot use import statement outside of a module. Okay, so let's just try. Require. Let me see. Require ethers. Yeah. Yeah, I think like this is going to work. Require ethers. Then here ethers dot contract. Okay, let's try like this. Ethers is not defined. So what am I? No. What am I doing, Julian? I'm forgetting everything. It's like this. All right, so let's try again. Unsupported transaction. Awesome. So contract runner doesn't support sending transactions, but I'm not. But the thing is, I'm actually not sending. Okay, no, I have an incomplete function signature. So it thinks I want to send a transaction, but I actually just want to read the blockchain. Okay, so we have an incomplete, yeah, look, we actually need all those things. So that's why it's not working. So let's put everything here. It needs to be on the same line, I believe. I don't think it needs absolutely everything, like the virtual and override. I don't think this is necessary, but The view is what is important. The view and the return. Okay, so now I think you understand better what we want to do. We just want to read from this. Let me see. Rather, get amounts out is not a function. Okay, so function. So why it's not even a function? Get amounts out. Invalid fragment. Okay. We have the it's not happy. Invalid. So let's try. Yeah, this virtual override. This is just for solidity. Okay, let's try to fix this. Okay, so now unauthorized server error. Let me see. All right, so maybe let me see if he has this process env, because maybe it's not reading it. Infra API key. All right, let me remove this from your site. So now secret mission Infra API key. All right. And why you're not happy, my friend? So problem of authentication. All right. So why that's the case? Let me try to fix this. Let me try to fix this because that's not normal. Okay, infra is here, so why? Maybe I need to just delete. Yeah, maybe I just need to delete my endpoint and create it again, because maybe that it has, for some reason, maybe it's not active anymore. CC. Okay. Maybe I have the wrong one. Let me try again. Cool. So now we have something. Okay, now it's working. So let me go back inside. I leak my key anyway. Who cares? I'm just gonna destroy it. So now let's do it again. Okay, so now we have the result. So why we have this really weird thing? So first of all, we have, this is an array. Okay, so we have two things. So amounts 1, 0, and 1. So let's separate this. Okay, so here we have actually two number, the amount out in terms of USDC and the amount out in terms of Ether. So here we don't have a normal JavaScript object in return, but we have a weird thing called a big int. So that's because the numbers on a Solidity smart contract can be much bigger than the max number you can represent in JavaScript. It's a 2 power 256 minus 1, so the biggest number on the EVM, and this is way bigger than the biggest number in JavaScript, which is 2 power 64 minus 1. So to solve this problem, we use a JavaScript library that allows us to manipulate this big number, and so we get one of these big int object from the blockchain, and we can transform it to a string by using toString like this. All right, so let me see. Let me see what we have. Okay, so the number, basically we get some USDC, back, but this is basically like some change, like some cent, because you have to see that here this is actually a very, very small number. So this time 10 power minus 6. Okay, so if you want to have it in USDC, so this is actually less than $1, maybe just 10 cents or something like this. And here we have the number of ether that we're going to have. So basically we are going to have one third of an ether. And so we need to decide, okay, well, we have this number here, so what is going to be our tolerance? So if you you have to consider the volatility in one day. So on average, you'll have to study, hey, what is the volatility of Ethereum over a certain time period? Because this is also going to be related to the block timestamp limit that you're gonna put. So if you put the block timestamp limit of, let's say, 10 minutes, well, what's the average volatility of Ethereum over 10 minutes? And maybe you're gonna see, okay, on average is 1% for 10 minutes. Okay, well then you can try to model. So it will require a little bit more study, but this is doable. You can study the distribution. So for example, what is the at the extreme, how many for example, if we go at 1 standard deviation, 2 standard deviation, how many percent is this? And let's say we do 3 standard deviation. Now this is extremely unlikely that we do this in 10 minutes. So that could be your limit. But I can tell you from experience, if you have a small time frame, a couple of percent is probably okay. So let's say 5%. Okay, so we are willing to accept 5% less. Okay, so how are we going to do that? 5% less. So let's do this. Amount ETH. Let's call this ETH mean. Okay, so amounts out of 1, and yeah, someone asked why it's a string, because it's a number. I just explained it before, because we are dealing with big numbers, so we need to use a special library. So here we cannot do something like this. We cannot do times 0.95, for example. It would be easier, but we cannot do it. So instead, we need to use the function of big int, and I think it's this one, multiply time 95, and then will be divide by 100, but I'm not sure. So we're gonna check the documentation of Ether, see if it's big int, like I think. Oh no, it's big number, sorry. So, okay, one of the biggest change in V6 is that big number has been replaced by the built-in ES. Okay, interesting. So now it's built-in big int. There's plenty of online documentation. Okay. Okay. So how does it work? Big int, exactly. I want to multiply. So is it mul somewhere? Multiplication. Oh, we can actually do it. Turns out we can do it. Okay, interesting. So let's try it out. Because this is built in by JavaScript. So yeah, maybe this is going to work. Let's try it out. Yeah, once we have this, it's gonna be much easier. So cannot mix big int Okay, so now it tells me I can't do it. Okay, so let me see. This maybe because if I have a big int. Okay, so maybe. Okay, maybe I need another big int. All of them maybe needs to be big int. Is it how we do it? Yeah, I think so. Big int. Let's try it. And now it's okay. Now it makes sense. So let's try toString. Okay, let's see this. All right, interesting. Yeah, now it feels like it makes sense. So let's just divide those two numbers. I'm pretty sure it works, but just to be sure, let's just divide these two numbers, and it should be 95%. All right, 95%. Amazing. Okay, so now we have what it takes. So next, so now we have our tolerance. Okay. 95%, and of course, as I said, this is you have to. This is depending on your block timestamp. Okay, so now we need to define we need to know the current block timestamp. So how are we going to do this? We need to know the latest block timestamp, and then from there we are going to add a few timestamp. We're gonna calculate what's the limit in the future. So you know what? I don't know how to get current block timestamp infra. I'm sure there is a way to get it. It's ETH. Get block timestamp. So we can. Okay, so and what is this? What is this parameter here? So the parameter is a string. Okay, so how about get? Hey, can we get it with Ether? Get current block time. Maybe there is a way to get it, but maybe we have to do it in two times. Like maybe we need to say, hey, what is the highest, the current block, and then what is the block timestamp? But I don't. Let me see if there's a way to do it. Okay, so there is a way. Oh, okay. So seems like there is a way to do it. Provider get block latest timestamp. Okay, let's try that. Timestamp. So this is infra provider, is it? Let me see. No, we just call this provider. Get block timestamp. All right, so let's console log this, see what we get. So I'm not sure this is going to work. Undefined. Okay, so let's try to see if we get the block at all. Because if we get the latest block, then we could. Okay, we get something. Nonce parent hash timestamp. Hey, we do have it. So let me see. Block timestamp. Yeah, we do have it. So 171 something. You know, let's just check what is the current block timestamp we find on the website. So 171. No, let's paste this 17. Yeah. makes sense. I think it's very close, so I think that's correct. Okay, so let's get back here. So this is the block timestamp, and so here I'm gonna say time limit. So time limit, how are we gonna define this? So let's say it's valid. So our 5% tolerance, this is valid basically for 10 minutes, okay? So 10 minutes, so plus 86,400 time 10. Yeah. What am I saying? No, we have 60 seconds in 1 minute. Okay, not okay. 60 seconds time 10, and now we have the correct time limit. Okay, and so next, so we have our two parameters here, ETH mean and time limit. So next, what we need to do is that to create an object to interact with our DCA smart contract. So basically, we will need to deploy our DCA smart contract, and once we deploy it, we're gonna get the address. Okay, so we'll get the address like this, 0x something, and then what we're gonna do is that, so why is not happy here? Why? Oh, because we're, okay, let's redefine this. So let's call this DCA. And what's the function we want to interact with? So let's get to remix. The function we want to interact with is this one. Right, so let's get here. All right, function invest, and so here actually I can tell you right away that this provider is not going to work. Okay, we will need a signer. We need to create a signer. So let's see this later. But yeah, here provider, we need a signer. With the current provider, we can only read data, but we cannot send transaction. And all right, so here this is the DCA address. And how are we going to do this to send the transaction? So we're going to call DCA invest. We pass ETH mean deadline. All right. And after, what we're going to do is that we are going to wait for this transaction to, so this is going to send the transaction to the blockchain. And after that, we need to wait. So wait, all right. And we're going to get the transaction receipt. And only at this stage, our transaction is mine, and then we're good. And so after, we're just gonna, the next interval of we're just gonna wait the next interval. Okay, so it's gonna be in another month basically. All right, so yeah, so this is basically how you would do it. Yeah, and so you could, so here the problem is that if we want to test that, it's actually a little bit more complex because Uniswap is on mainnet. So obviously we don't want to deploy our smart contract on mainnet. But what we're going to spend some real money. But what we can do is using the forking function of Foundry. And with the forking function of Foundry, basically we can test it on mainnet with the state of mainnet, but without spending any money. And here, just a side note. So actually, we're gonna have a little problem here because I said here that we need a signer, and this provider is not going to work. So we need another way to connect to Infura, and also we're gonna need to pass our private key, because to send transaction we need to spend Ether. So this is going to be, the final version is going to be slightly different here at the provider level. But anyway, this is all I wanted to show you today. Because if we still do the thing with the forking, with Foundry, it's going to take too much time. All right. So let me see in the chat what we have. We still have some people. Yes, awesome. So any last question before we finish? No? So what I show you here, I just show you a very simple way to do DCA, but you can actually you could actually sell this as a service. So you could do an app where you let people you let people deploy this investment contract, and you on the back end you have this cron job that is going to basically call the invest function of all your customer every month, and then you can take a small fee. So every month, I don't know, maybe you can take like 0.01% or something like this. It was actually the initial version of this stream was an app like this, but to be completely honest with you, I really misjudged it. So I prepared this tutorial for a couple of days, and so yeah, that was the initial vision, was to do a full app where you can launch this as a service, and it was way bigger than I thought. But I can maybe show you a little bit some visual, because maybe in the future I would release the complete version of that, but that would be like a huge tutorial. So let's see what we have. Yeah, so it looks like this. Basically the app I did initially. So you click on the connect button, then you will have an input that tells you what's your budget. Then you click on connect on deploy DCA, and so it's going to deploy the DCA smart contract, but going through a factory smart contract, so like an intermediary contract. And thanks to this intermediary contract, you as a service provider, you can know the address of all your customer, everybody who deployed DCA. So and then after, if you do a cron job, what you can do is you can query this factory contract and say, hey man, give me the list of all the DCA contract, and for each of them you do the DCA. But yeah, that's a much bigger project. So really the first step would be to try to do this for yourself, and maybe not choose a chain like Ethereum that costs a lot of money, but maybe you could choose something like Base, and you have the same kind of exchange as Uniswap on Base. You have a lot of Uniswap clone there, so it's much cheaper, and you try to make it work. And then once you make it work for yourself, then you can try to make it work for more people. All right. So some people ask, can I download it? So all this live stream, I'm actually planning to, I'm going to give you more information in the future, but I'm planning to do a sort of membership for Eat the Blocks, where basically you can pay, you get access to our private community, and we give you access to the source code of all the live stream that we do. All right. But I will give you more info about this in the future. Okay, guys, so I hope that it was instructive. And yeah, thanks for following up to here. And I will see you next week for more tutorial. All right. Have a good day, everybody. Bye.